If you have ever tried to scroll through a massive spreadsheet with over 2 million rows, you know exactly what happens. The application freezes, the cursor spins, and eventually it crashes. Flat files like Excel or CSVs are powerful tools, but they hit a hard processing wall when handling massive data sets. To get past that wall, enterprise analysts use a relational database management system, or RDBMS. This is a highly optimized environment built specifically to store, secure, and query massive amounts of data without those performance drops. Instead of keeping information in one massive table, a relational database breaks data down into smaller, interconnected tables. An RDBMS uses this blueprint to enforce strict rules at entry, catching errors before they corrupt the dataset. To navigate this environment, you need to know its core building blocks. The master structure is the schema. This logical blueprint holds related tables together, like a sales schema holding folders for customers and transactions. Inside that schema are the tables. These are individual grids of data storing information about one specific subject. Every single row in that table must have a primary key. This unique identifier cannot be left blank, mathematically eliminating duplicate records. Then we have the foreign key. This is a column in a second table that points directly back to the primary key of the first table, establishing the actual relationship between the two grids. These primary and foreign keys provide the essential wiring. They allow separated, highly specific tables to communicate and function seamlessly as a single coherent system. When data is spread across multiple interconnected tables, simple click-and-drag interfaces struggle to define the specific paths needed to retrieve information at scale. To interact with these systems, analysts use structured query language, or SQL, to send programmatic instructions directly to the database engine. Let's look at this sample employees table. We have 4 columns, an employee ID as our primary key, a first name, department, and salary. We will use this as our testing ground. To retrieve the names and departments of our employees, we write a logical command. We use the select clause to specify the exact columns we want, first name and department, and the from clause to tell the database to look inside the employees table. Every extraction query you write relies on select and from. They are the non-negotiable foundation, defining exactly what data is needed and exactly where it lives. If you only want to see employees in the sales department, you add a where clause. Think of where like an active slicer in Excel. It evaluates a specific condition, department equals sales, and filters out any rows that do not match. To organize those remaining results, we introduce the order by clause. If we want to sort our sales team from highest to lowest salary, we instruct the system to order by salary descending. By stacking these statements, you dictate the output. Where and order by allow you to take a raw data dump and systematically shape it into a targeted, actionable view. Often, you need to summarize information rather than list it out row by row. This requires the group by clause. It works by aggregating identical data into single rows, and it is almost always paired with math functions like sum or average. Pause the video and write out the exact SQL query required to calculate the average salary for each department. Let's check the code. You select the department column and apply the average function to the salary column from the employees table. Finally, you tell the system to group by the department, condensing the results into a clean summary. Mastering the group by clause pushes you past simply looking up records. This is the step where you begin extracting structural insights from the data. By executing these commands, you are moving from manual data entry to logic-based analysis. You are now using the same structural framework used by professional data analysts. Looking at this list of basic clauses, you can see how SQL functions similarly to a structured sentence. Select specifies the columns, from specifies the table, where filters the rows, order by sorts the results, and group by aggregates the data. Your next operational task is to complete Self-Check 3.1-1 in Google Classroom. This will verify your syntax knowledge before we move into our live, synchronous MySQL practice session this afternoon. Fluency in this basic syntax is the required foundation. It is the bridge that allows you to access and analyze the information stored in professional database systems.